Today we're going to be looking at lessons 2.6 through 2.8 for a quiz review that's upcoming. So the first question, we need to think about the point of intersection of two lines. So the point of intersections of two lines is always going to be a point. So I'm going to look where lines X and Y intersect, which is here. And so that means my intersection is going to be A. Here we're thinking about the following statement. If we have a segment XY equals YZ, and then we think about X, Y, and Z all being on the same line or collinear, then Y, which is in the middle, is what it's saying, is the what of the entire segment. So if these points are collinear, and if one side of the line is equal to the other side of the line, then point Y is going to be the midpoint. Of XZ. Here we're asked to name the definition, the property, postulate, or theorem that justifies each statement. So we only need one for each statement. So if you look here, we have Y equals 3, then 3 equals Y. So they've switched where the number and the letter are for the equal sign, and this represents the symmetric property. And then the next problem, you start with m plus 2 equals n, and then you have m equals n minus 2. So if you think about trying to get m by itself here, what did they have to do? They had to subtract by 2. So this is the subtraction property. Here, we're trying to determine whether the conjecture is true or false. So if you think about where two planes intersect, and then it says two planes intersect, the planes can intersect only at one line. Is that conjecture true or not? And that is actually true, because planes, when they intersect, do only intersect at a line. They do not intersect at a point. So this would be true. Next, we're going to be naming some more definitions, properties, postulates, or theorems. So I'm going to give you a statement and think about which property it represents. We're given that XY is congruent to ZA, and then ZA is congruent to XY. So again, they just switched which side the segments are on for the equal sign, which shows symmetric again. Then we think of the top example here. If AB equals CD, then AB plus XY equals CD plus XY. This, you can say addition postulate here, but you want to be more specific since geometry is involved and since we're talking about segments. So we're going to say the segment addition postulate. And then the bottom example, excuse me, if angles 3 and 4 are vertical angles, then angle 3 is congruent to angle 4. You want to think about whether vertical angles are congruent or not and what makes that so. And so you want to think about the vertical angles theorem here. which states that if they are vertical angles, then they are congruent. And here's another one. We have if angle 3 plus angle 4 equals 180, and angle 4 plus angle 5 equals 180, then angle 3 is congruent to angle 5. So this is technically, it could be, again, two different properties, but we want to be using the most specific property here. So you could first say that it's transitive property, but we're talking about supplementary angles here. So there's a theorem that talks about supplementary angles, and that's the congruent supplements theorem, or theorem 2.6. So we're going to use that as our answer to be the most specific here. And then finally, we're going to find x, but we need to consider what we're given. So if the measure of angle D equals 2x minus 3, and the measure of angle E equals 3x plus 5, it says angle D and angle F are supplementary, and angle E and F are supplementary as well. So if we think about the last example where it was the congruent supplements theorem, which made the first angle equal to the next angle, if you look there, see how they made angle 3 congruent to angle 5, and angle 4 was repeated. This is actually the same type of problem. So what we can end up assuming then is, or figuring out, is that angle D is equal to angle E. And that will help us solve for x. So I'm going to combine like terms here to solve for x. I get 2x equals 3x plus 8. And then I'm going to need to combine the x's, so I need to subtract the 3x from both sides. So 2x minus 3x gives me negative x. And that's negative x equals 8. And to have x by itself, I need to divide out the negative 1. So it becomes x equals negative 8. Now, most likely you're not going to have the x value here be negative, but since I made up the numbers and I am now looking at how they work out with each other, my answer is negative, but I would not expect an answer like this on the quiz to be negative. Okay, so, but the same idea will be on the quiz in terms of the congruent supplements theorem, where if you have an angle and another angle supplementary to the same angle, then they're going to be congruent. So you do need to know that part. And that concludes our quiz review. And you'll see a problem like this on each problem like this on the quiz.